Hi, this is our fourth of 5 videos of 1.5 graphing techniques, and this is actually the bulk of the work here. And I tried to get as many examples on the board as I could fit on here, and there's 4 of them up here. And so I'm applying some transformations to these particular functions on these numbered. But you have to know the basic graphs, and the basic graphs was talked about earlier. And y equals x squared looks like this. It's a little parabola, and if you don't know what these shapes are, you can always plot points. So 0, 0, 1, 1, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and then plot those points. Looks like a bowl kind of shape. Then y equals x cubed. 0 cubed is 0, 1 cubed is 1, 2 cubed is up there at 8. Now, it didn't have enough room, so that's kind of what the shape looks like, an inverted S. Then y equals 1 over x, this is the reciprocal function. And if you notice, there's an asymptote at y equals on the y-axis, because if you put 0 in, it's 1 divided by 0, and you cannot divide by 0. So it looks like this shape. I call it a little wicked butterfly. If you kind of turn it sideways and put a little bitty thing, it looks like a little butterfly there. And then this one, y equals the square of x. Notice it starts at the origin, because you can't put negative numbers in. So, but anyway, if you're not familiar with these graphs, these basic, what I call parent graphs, the book calls basic graphs. These graphs, you need to familiarize yourself with them, because you can't apply a transformation to a graph that you don't know what it looks like in the first place. So you got to know what the shape is before you can do anything with it. So, and these are not all of them. There's actually more than this. And so, but anyway, on number 40, you take the basic graph, which is this parabola, and it's y equals x squared plus 4. So this one, you have to move the graph up 4 units. That's a vertical shift. That was our very first transformation that we talked about in our overview. So you take the parabola, take the point at the origin, and move it up 4 units. And then the one that's at 1, 1 will go up to 1, 5. 1 plus 4 is 5. And negative 1, 1 will go to negative 1, 5. And then the rest of the graph goes with it as well. It doesn't get any narrower than what it already is. It doesn't get any wider. It doesn't get upside down because there's no negative. So the only thing that's been applied to this one is the plus 4. So it just moves the graph up 4. It's not even going left to right. Now that's what's happening on this one. This one on number 46 actually is moving left because it's a negative 2. We'll make that 0. And then at minus 3 we'll move it down. So now I like to use the point at the origin if it's there for these types of problems. It's kind of like what I would call a pivot point. So now y equals x cubed was this one, remember? So it's not going to get upside down or anything, but it's going to get shifted over left and then down 3. So this point right here at the origin will go 2 to the left and then 3 down. And this point right here in the first quadrant, that's 1, 1, you got to move it 2 to the left and then 3 down, which moves there. The one that's in the third quadrant, you move it 2 to the left, so it's going to be at negative 3. So it goes like this. So, and the shape will look very similar to what you started with, except it's just been moved mostly down in that third quadrant. So 2 to the left and 3 down. So it can get upside down because there's no negative. And that's what this one's going to do. The negative is going to turn this one upside down because there's a negative in front of the 1 over x. So if this is 1 over x, the negative is a vertical reflection. So the wings of this wicked butterfly are in the other quadrants now. So because this part is going to go up here, and this part is going to go down here. So it looks like this. There's still an asymptote at x equals 0, the y-axis, because you don't move it left to right. But that's what this graph looks like. And then this one is the square root function. Now this one's going to get moved 1 unit, but which way? It's going to be 1 unit to the right because it's x minus 1. And then you got, why I thought it would be going down. And it would be going down if it was the square root of x and then the minus 1 on the outside. If the minus 1 was on the outside of the radical, it wouldn't be associated with the x, so therefore it would be a vertical shift down. And not this one. This one is a right shift because it's associated with this x. So we go 1 unit to the right. So this pivot point right here is going to go 1 unit to the right, so it's there. Now, I'm not going to just now copy and paste the rest of the points because it's a negative 4 out front. Now, the 4 is a stretch factor. So this point right here will go up 4 times. So I'm going to stretch it out. But the negative is going to bring it downstairs, down into this quadrant. So 1 unit to the right of that point, and then 4 down. So it's 1 unit away from this other point, like it is up here. But instead of 1 up, it's going 4 down because of the negative 4. And then the rest of the graph. Notice the difference in the shape. You can tell this child, what I call the child graph, looks like its parent graph. I mean, they're in the same family, except it's been turned upside down and stretched because of the negative 4, and it's been moved 1 unit to the right. So here is a series of examples. I'm just going to let you know, you're going to hit a graph that you may not recognize. You may have to go back in the book somewhere and find the parent graph, the basic graph for that particular shape. There's no shame in that. I just can't give you every single one that you possibly will ever see. So there are others. So, but the transformations will be consistent. So, I mean, this one went 1 to the right, this one went 2 to the left. So whatever the function is, if it has that, it's going to have that same thing going on. So, all right. So this concludes 1.5, the 4th video. We have one more to go out of this section, and thank you for watching.